suppose we are given a plane like this. So there is a plane that you can see, and suppose that there's a line. It goes through the plane, comes out the other side, of course, and here somewhere here. Now, say there's a person that's looking. Look at the view from this direction. Okay, that's the eye. What this person would probably see, well, this person will see first, of course, the plane right here, and then that's the line. Line goes out here, goes the side, right? Suppose that we know a normal vector, something like this, to the plane, and of course this is perpendicular. Now, let's give names to those angles. So this angle here, let's call that phi, and so this angle here, let's call it theta, and we know that phi plus theta is actually 90 degrees. Yeah, complementary. And in here, right here, this angle here is also theta, because the opposite of angles. Now, for sure, you will usually know that the direction vector of the line. So in perspective, you'll be getting something like this. You have the line giving you this vector u, and the normal, here it is where they meet, normal, and there's the angle theta. So the sine of this angle phi, recall that this is angle phi right here, the angle phi, so sine phi. Now sine phi is actually sine of 90 degrees minus theta, but because of course they're complementary, this means this is cosine theta. But if you look at this illustration here, cosine theta is an angle between the two vectors u and n, and so the cosine theta is equal to u dot n. This is a definition of a dot product, and u magnitude and magnitude of n. And to make sure that the angle theta is acute, we absolute here this. And but because what this is in fact sine, recall this is actually sine phi. Don't forget the notion that we want to find angle between the plane and the line, and so this is sine phi is equal to this thing here. So eventually aims to calculate phi. So sine phi is the inverse of sine, or arc sine, u dot n over magnitude of u and n. So for this problem here, we see that the normal to the plane is 1, 81, and 1. The coefficient of both x, y, z. So I have let n be 1, 81, and 1. And then here, it is not very clear to be seen. We just express the lines in parametric form. That would be 4t plus 1. And then this y will be 3t minus 1. And finally, z will be t minus 2. So here, the coefficient of t tells us the story about the direction vector. So that this implies that the direction vector of the line will be 4 and 3 and 1. And so for us to just use this formula, first we want to find the n dot u will be 1 times 4, and -1, 3, and finally 1 and 1. And that outcome should be 2, and the magnitude of n is surd 3, and the magnitude of u would be surd 26. So again, just by using the formula again, then you have sine phi, that the phi is the angle between the line and the plane. You have 2, surd 3, and surd 26. In other words, the phi will be the inverse of sine. And just the usual calculations, get a calculator. You will get approximately 13.1